Hi everyone, this is Data Dawn. I'm here to talk about various transformations in Informatica Designer in 5 minutes. This section lists you the various transformations like router transformation, sorter, aggregator, lookup, update strategy, sequence generator, rank, normalizer, stored procedure, external procedure, custom transformation, transaction control. So these are the various transformations that we can use in our mapping to perform various operations in our mapping. So let's briefly see what each transformation actually does. Router is basically to route the data into various mapping streams. As you can see, it looks like the icon looks like this, and then it has a property groups. You can specify any number of groups. It basically acts like a case statement. Okay, you can just set a condition through which the data can flow. Okay, so there are like various ports. It's connected. It's an active transformation. Okay, it can used link the source data of one pass to multiple filter conditions. So as you can see, the router looks like this. Incoming data can flow to different targets based on the condition that you set up in the router. Comparison between many of you can ask a question: what is the difference between filter and the router? Filter just has only one condition. The router can have a multiple condition. To be simple, filter is like a if statement. Router is like a case statement. For any application developers, can understand this. Okay, sorter is basically to sort the data based on the key that you define in a sorter. Sorter can be used ascending or descending. You can just, it's an active transformation. It is always connected. Okay, it has input and output key ports. Okay, it is used to perform an order by operation in a incoming data. Sorter is often used just before the aggregator. Okay, so aggregator works well only if the input data is sorted. So you can set a distinct option which will discard the duplicate rows. It can access an active transformation with distinct option, else pass it. Aggregator transformation is basically used to aggregate a value. You can do aggregation functions like sum, count, max, min, etc. So it is an active transformation. It is connected. It is posed or mixed variable allowed. Group by is also allowed. You can group by certain columns. It is used for standard aggregation. So these are the various functions that you can use with the aggregator, like average, count, first, last, max, median, min, percentile, standard deviation, sum, and variance. You can use the various expression by using the expression window. You can also use complex expressions like sum of addition of two columns, which is required in many calculations. This is the property of aggregator. We can set this input as a sorted input if you are using sorter. Otherwise you have to set non-sorted input, which will decrease the performance. You can also put the cache sizes in the aggregator. Aggregator works efficiently with sorted input data, like I said before. Data can be aggregated more efficiently, decreasing the total processing time. Otherwise the aggregator has to manually sort the data and do the calculations, which will decrease the performance. Okay, data must be sorted according to the order of the group by ports. So this is just a simple mapping which shows you how the aggregator actually works. You can join order and order items, and then get an expression, get it out of expression, and then aggregate it and put it in the target. Okay. Lookup transformation is basically used to look up the data. It is basically to look up the key values of incoming data. For example, if you're getting a store number, you can get a store key from a data warehouse using lookup. So likewise, lookup can be used in variety of reasons. You can look up a salary of an employee using an employee number. You can look up a manager of an employee using an employee number. So those kind of things can be done using lookup. So there are like two types of lookups. One is connected and unconnected. This is basically how the lookup works. You can give the order ID and then get the date entered and various things. this is how the lookup condition lookup looks like this. A lens on a data window. This is the properties of the lookup. You can specify a lookup condition. You can override the lookup SQL using lookup override SQL. You can set a default. You can set up a default query to execute when incoming data is coming, and you can use either do native database connection object name, or you can specify a predefined or you can define a database connection at runtime. These are the additional lookup property, like such cache directory, make cache persistent. If you keep a cache persistence, it won't refresh every time that job runs, so the efficiency will be greater. You can set up multiple conditions for lookup by just clicking up a new button shown here. The lookup kind of two type, like I told you, it can be either connected or unconnected. Unconnected lookup can be used as a function in any expression. You can also put a conditional lookup. Conditional lookup is basically, uses the unconnected lookup as it's shown here. This expression will call an unconnected lookup called LKP. Okay. The difference between connected lookup and unconnected lookup is shown here. It is a part of a mapping flow. This is separate from mapping data flow. Returns multiple values by linking input and output. Returns one value. Okay. Executed for every record passing through the transformation. Only executed when lookup function is called. More visible shows where the lookup values are used. Less visible as lookup is called. Some expression default values are used. Default values are used. Cache or no cache, which basically depends on the data size. If data size is very less, you can do a cache. If a database that you're trying to look up is very huge, you don't have a cache. So as you can see, the rule of thumb, a cache is if the number of and size of a record number is very small, you can do a cache. Additional lookup cache option is shown here. Cache file name prefix you can set. Recache from source, overrides. Okay, dynamic lookup cache. These are like for a persistent cache. What is the lookup values? Update strategy is basically, tells you either to insert, update, or delete a record. Okay. Target refresh, a single snapshot, sequential snapshot, incremental snapshot. Update strategy, you can put an expression here if either dd update or dd delete. Sequence generator is used to generate sequential value. It basically works as an Oracle sequence. You can create a sequential number using the sequential generator. This is basically used to create database keys. As you can see, these are the properties of the sequence generator. You can set a start value, which is default as 1, increment by 1, maximum end value, the current value, circle. This is stored in the database, and when the database that the mapping starts, it will pick up the condition. Rank transformation is basically to rank the incoming rows. This basically works like a Oracle rank function. Normalizer is used to normalize the incoming rows. It will split a single record into multiple output records. Stored procedure is used to invoke a stored procedure, either it's Oracle or any other database. Relational connection should be there. External procedure, again, it's like a used to execute external procedure like a Java, Visual Basic, C or C++. Custom transformation is some transformation which is created by you. This can be done by transformation developer tool. Transaction control is basically used to control the number of transactions. You can either commit, discard, or revoke, roll back the transaction. You can set the limits on after how many rows you want to commit or roll back. Thank you very much. This is all I have to talk about various transformations in Informatica Powercenter Designer. Thanks for watching my video. Please subscribe and thanks. Come back for more videos. Thanks. Bye.